So today I'm going to talk about Project Escher and specifically what happens when 3D printers work together. Can I get a show of hands? How many people in here have actually used a 3D printer before for fun, for work? All right, wow, this is such a cool community. This is awesome, guys. So today I'm going to talk about Autodesk and 3D printing. I'll be talking about what makes 3D printing slow and what we're trying to do to make 3D printing go faster. So Autodesk, I came on board at Autodesk in 2014. This was about the time that Autodesk started up Spark, which was this idea of an open 3D printing platform. And since Spark, what we've actually done is decided, oh, that's cool, 3D printing, allowing people to build apps for that. But what if we just took every single chunk of Autodesk IP and tried to make that available through a platform for people to use? So anyway, without that as the background, as part of the original Spark team, what we were doing, what we're still doing, is building a slicer from scratch. So a slicer similar to MakerBot Slicer, Simplified 3D, Cura. How do we take a mesh and, as intelligently as possible, decide how the toolpaths will be driven for 3D printers? I want to take this opportunity for all of you, if you're currently using 3D printing, 3D slicing software, check out NetFab. I tried them all. I'm a huge fan of Simplified 3D, and by far the coolest, most useful supports I've ever used are from the newest version of NetFab. It's free. What you'll do is sign up for NetFab, and even though you sign up for the paid version, after 30 days, you still have access to all the slicers. Definitely check it out. The support that they offer in there is just really, really cool. And so specifically what I've been doing is I work on a team that's part of taking this slicing software and integrating it into NetFab. So before I was working on that, I was a part of a team that was doing hardware development. And Autodesk doesn't necessarily do a lot in hardware, but in order for us to really innovate and create some new solutions within 3D printing space, we needed to create new types of hardware to work with the software that we were working on. But the higher up said specifically, hey guys, we want to print big stuff. You know, we're printing the average 3D printer, you're going to print something that's the size of a loaf of bread, you know, your standard MakerBot printers. And we're like, no, we want nothing to do with that. It's really time consuming, it's really expensive, and it's slow. I don't know if you guys have ever, even just in your standard MakerBot printer, just tried to print the full volume, especially if you want to print precise. It just takes forever. And so I guess I want to talk a bit about this idea. When's the last time that you were stuck in a line? Whether it's at the DMV or at a grocery store or even in traffic, and just that exhilarating feeling that you get when all of a sudden a new lane opens up. I'm fascinated by that feeling, and really that's kind of what drove us, and so that's what I'm going to be talking about. Normally with FDM, if you want to print faster, you can use a bigger tool. And actually, I'm really excited to hear more about what Nathan's going to be talking about, this idea of using larger tools. So that's one way that you can print faster and print bigger. Another way is you can actually move faster, so you can try to move your nozzle around as quick as possible. And normally in the ecosystem, that's about it. If you want to print faster than that, you just take both of those knobs, crank it to 11, and hope for the best. So inspired by the good old DMV here, we said, what if we actually used multiple tools? We had no idea how, but we thought it was a cool idea, and when we were just brainstorming, because we were given this directive to print big, like, crap, okay, how are we gonna do this? So through brainstorming, we said, okay, well, what if we just had a ton of drones? We just have this army of drones. They can go around, each one can print their own little part, work together, and they're like, that's crazy. That's a great idea about how we're gonna make this work. And so we said, okay, what if we just had a ton of tanks that kind of drove around? Okay, that's slightly more realistic. Like, maybe we can pull that off. And again, it's just a good idea, but it's just really hard to implement that. And I guess really that goes back to this idea that Autodesk really really likes doing these sorts of things, but the hardware that we wanted for this idea just didn't exist. And so we had to make our own. And what we ended up doing just to prove this idea out is we took 2 printer bots and just threw them on a giant rail. And that was our Escher version 1.0 printer. It was 2 separate printers working together to print one part. And I'm not sure if this will play or not, but it's a cool video that's showing up here. Oh, there we go. So anyway, as you can see, this was our first attempt at having 2 printers work together to make one part. And okay, let's see if I can transfer back. So since then, what we did is we actually made a second machine, and this was with 5 separate printers working together. This is actually you can see a newer print of this geometry back there. I don't know if some of you saw it. It's we printed the newer version within the last few months. Definitely go check that out later on. So we were able to make hardware that allowed us to make this new type of software for having multiple printers work together. And that's great. Our Autodesk, we have to use this kind of hardware. We have to dive into hardware. But Autodesk really, I guess you could say, puts hardware more in the friend zone. we really love them, but we're not something that we're looking to commit. We really want to provide in-depth experiences with software that supports the hardware. So anyway, to that end, what we're really excited about is we're working with third-party hardware vendors such as Cloner 3D, Titan Robotics, and actually we have a few other that are going to be announced later on. But the general idea is it's kind of putting the cart before the horse. We created this software solution for hardware that didn't exist, and we're so excited that it's something people are actually getting on board with this. We actually have people that are making these machines. It exists now. So be on the lookout for more people making Escher-enabled hardware. So that's cool. We've got these printers that all work together, but what actually happens? What does this mean when you have multiple printers that are making a single part? So I want to talk about, with this type of hardware, these multiple applications that come from that. Really, even though we could have, like the army of drones, talking about finding the sweet spot as far as number of printers. And then I also want to talk about targeting reliability. So the first thing, this is just like a quick thing, you think about the people that would actually be able to use this kind of technology. And for me, I'm thinking about service bureaus. I'm sure a lot of people in service bureaus have to make a decision. Do we buy 10 of this smaller or 10 of this cheaper 3D printer? Or do we, for the same money, buy a larger 3D printer, but it would only be one-off? That might enable you to print bigger things, might enable you to get different clients. What's really great about this is people that have an Escher-enabled machine are now given the opportunity not just to print big, but actually to print big and have it be on a realistic time scale. Well, at the same time, all of those printers, they never stop being regular one-tool printers. You can still have each of them do their own job. So now that we talked about that, really let's bring this down to reality, dig you out of the trough here a little bit. How many extruders do you actually need on a printer? So what you need to think about is how big is each gantry. So if you can imagine a printer that's about the size of like a fourth of this stage up here, so like about here. If you have each printer taking up this big of an area and it can move around, you could fit 10, maybe 20 on here. But once you have 100 printers, they've got nowhere to move. There's, physically you can only fit so many printers together. And so to that end, you really have to be cognizant about what's realistic. And also it becomes a bit of a design challenge. One of our interns back here has had the awesome opportunity of designing Sean's back there, of designing a bot that's able to squish together and get as close as possible together to allow each bot to be able to move around. So the really big thing, the takeaway with all of this, and it's both a big pain point, but it's something that we're really proud about taking this head on, is reliability. How many people, I saw a ton of people out there who have used a 3D printer. I want to get a raise of hands. How many people have never had a failure with their 3D printer? All right, so To that end, let's talk about chance of success with a 3D printer. Depending on how reliable your printer is, you have maybe 1 out of 10 prints might fail. Or if you're really, really lucky, 1 out of 1,000 prints might fail. Now, that's a staggering number, but that's with the right system setup, that is achievable. So that's great, but what happens when you actually put 5 printers together? It's basically like playing craps. If you have a 1 in 1,000 chance of failure, now you have a 5 in 1,000 chance of failure. And what happens now if we actually implement a system where there's 100 bots? With the 90% chance of success, you don't want to go to Vegas with those odds. This is ridiculous. So even with 1 in 1,000 chance of failure, when you have 100 bots, the fact is that takes you down to a 90% chance of success with 100 bots. And so that's something that our team has been working really hard on, is this idea of closed loop control. Being able to take a process, find an error, catch it before it ruins the print, be able to do something about it, ideally in an autonomous fashion, but even if not, at least being able to send a text message, say, hey, someone's got to check this out. And so that's technology that we're working on right now. Get ready over the next few months. We're going to be pushing out more updates about that. And a lot of this software we're making possible through NetFab. And specifically, the chunk I'm working on is actually a piece of open source software available through it. And so a lot of these things we'll be able to make open source and available for people to use. So today I talked about, with Project Escher, we have multiple printers working together. What's happening with when you can use this for different applications, talking about finding the sweet spot, and then also what we're doing with reliability. So that about sums it up. I guess, we can't help out next time you guys go to the DMV, but when it comes to printing faster, we're working on it. Thank you.